Today, mining is a large-scale activity that involves a lot of talented men and women, large earth-moving equipment, and sophisticated processes. But gold isn't as easy to get as it was in the gold rush days. Quite often, deposits mined today contain only microscopic bits of gold invisible to the naked eye. So many tons of rock have to be mined and processed to produce gold that you can see and use. That's why modern gold mines are typically large. It's also why so many people work at the mines. Mines offer a spectacular array of jobs and opportunities. The active life of a mine can range from a few years to more than 50 years. Worker safety is of the utmost importance, and the industry is very strong. A mine goes through 4 stages or life cycles. First, there is exploration of new gold deposits. Second, there is mine planning. Third, there is mining and processing. And finally, there is reclamation. Before any actual mining can begin, a process known as exploration has to happen. Geoscientists study the Earth and its geological makeup to look for signs of gold deposits. Geologists are people who study rocks and the Earth. These people are the ones who help start the mining process. First, they study rocks and make maps of a region. As they progress, they use more complex methods of finding out what is below the surface of the Earth. Using geophysics and geochemistry, geologists start creating maps that show their estimate of a potential gold deposit. To test the estimate, holes are drilled to identify where gold is concentrated. After collecting enough samples and data, the geologists can generate a 3D model of the ore body. This model shows areas within the ground that contain various concentrations of gold. With this model, geologists and mine engineers can design a mine plan. Mine planning is a complex and sophisticated process. It involves experts in nearly every field. Every cost is calculated, and every detail is evaluated. In addition, environmental conditions and resources are considered. During the exploration and mine planning stage, an environmental baseline is taken of the proposed area of the mine. This environmental information is used to determine potential impacts to the land, develop reclamation plans, and prepare permit applications. Before mining begins, permits covering all aspects of the mine must be issued. This information is also used to determine the impact on people and the local communities. Mines take an active role in communicating with local organizations and groups who have a vested interest in the company and the operations. The relationship between a mine and a community is very important. Using the geologic model, a blasting plan is developed. This plan is used by the drill and blast crews to lay out and drill a pattern that will safely and effectively fracture the rock for mining. Drill rigs drill hundreds of holes in a specific pattern for the blast. Then, the blast crew loads each hole with a blasting agent called ANFO, or ammonium nitrate and fuel oil. The blast foreman clears the area, sets up roadblocks to ensure worker safety, starts the warning siren, and calls, "Fire in the hole!" The blast fractures thousands of tons of material. Hydraulic shovels and front-end loaders load the rock in the haul trucks. These haul trucks hold about 240 tons of ore. That's 480,000 pounds. That's as heavy as 200 cars. Ore is rock that contains a concentration of a valuable mineral, in this case gold, that can be mined at a profit. Because the geologists studied the rock before the blast, they know which areas of the blasted material contain high or low-grade ore. While ore material may look similar, the concentrations or grade of ore within the material are different. The people who work in the assay lab determine these differences by subjecting ore samples to various tests. High-grade ore has more gold particles than low-grade ore. Grade is used to determine how the ore will be mined and processed. Ores can also vary in chemical makeup. These factors also play a big part in determining how the ore is processed. So that's why each block of ore in a mine is referred to by its grade. Rock not containing sufficient concentrations of gold is referred to as waste rock. Each block is mined out separately and delivered by haul trucks to a specific area of the mine site for processing or placement in a waste rock facility. If the ore is low grade, then it goes to a leach pad. If it is high grade, then it goes to a mill, autoclave, roaster, or other processing facility. A leach pad is a large pile of low-grade ore carefully constructed on top of a specially designed liner that looks like a giant thick sheet of black plastic. This impermeable liner and the deep layers of other dense materials on which it lays prevent the leaching solution from entering the ground below. A long network of hoses drips a weak cyanide solution onto the ore. The gold in the ore is dissolved by the cyanide solution and trickles down to the bottom of the pad. The solution collects in a man-made reservoir and is then pumped through a series of tanks containing carbon particles. The dissolved gold sticks to the carbon particles, which are later separated from the gold in a stripping process. The resulting gold solution moves on to another process stage. High-grade ore is sent to either a mill, autoclave, or roaster. The mill grinds the ore into a fine sand to prepare it for the final processing stages that turn the scattered, invisible gold particles into solid masses of gold that you can see. Some gold ore needs more processing before it can go through these final stages, which include a form of carbon leaching similar to that used for the lower grade ore from the leach pads. This is the case for ore that has sulfides in the rock, making it untreatable in the mill. The roaster removes the sulfides so the ore can be effectively processed through carbon leaching. Process facilities like a roaster generate tremendous heat. Water that is circulated through the plant to help control temperatures often generates large amounts of steam, like you see here. An autoclave is used to remove sulfides from certain types of ore. The ore is first wet ground and then put through the autoclave, where high heat and pressure are applied. Eventually, all processed ore ends up in a solution called a slurry, which moves through a series of tanks containing a mixture of weak cyanide solution and carbon. The gold bonds to the carbon, which is separated from the slurry. The carbon, now loaded with gold, is further processed to remove the gold and put it into solution. The gold solution is then sent through a circuit where the gold is recovered through an electrochemical process similar to the process used to make chrome-plated car parts. The recovered gold is then melted in a furnace at 2100 degrees Fahrenheit and poured into molds to form gold bars. However, these bars, called doré bars, are a mixture of about 85% gold and 15% silver. They are sent to a European refinery to be refined into pure gold bullion. Areas that are no longer needed for mining are reclaimed. When possible, this reclamation is done concurrently or while mining continues nearby. After mining ends, the entire mine site is reclaimed or returned to a natural-looking appearance, so that after a few years, it will be difficult to tell that any mining took place at all.